Great. Thank you. Welcome, everyone. Thanks for joining us. This is great. For the next 30 minutes, we're going to go ahead and talk about building a high-performance file system, primarily in AWS with Nasuni. My name is André Benguerel. I am a technical consultant for Nasuni. I focus on major accounts in a post-sales role. I'm located in the San Francisco Bay Area, and I focus on our big customers on the West Coast. And our company is Nasuni. Nasuni is headquartered in Boston. We call ourselves a startup, but we've really been around for about 10 years now. The last 5 of that being more in the enterprise. So we have kind of focused in on that. And we're currently at about 250 employees. So it's a fairly small company. It has a very startup feel to it. Just a quick show of hands. How many of you consider yourselves from a startup company or in a startup company? All right, good. All right, cool. So a lot of what we're going to talk about today applies to, one of the great things about Nasuni is it applies to a lot of different companies. So whether you're big or small, whether you have a large file workload or a large file footprint, a lot of the things we do will help you at Nasuni. We are also a advanced technology partner with AWS, so that was a big deal for us. All right, so here's the agenda. So we'll talk really quick about, we're going to talk about Nasuni UniFS and the basic NAS services it provides. We'll talk about our file synchronization and our collaboration that's included. And then we'll dig into how we actually leverage AWS, some of the services that we run there, and how that makes Nasuni what it is. It includes things like the different storage tiers, our operations center, our network the Nasuni management console, and then our global file locking. And then we're going to take a look at one of our customers that's a fairly significant user of AWS, Perkins & Will. And then at the end, we'll have about 10 minutes or so if you guys have questions. And I'd love to take questions, so keep that in mind. All right, so let's get started. So Nasuni provides the world's first cloud-based platform that allows you to store, protect, synchronize, and collaborate on all your unstructured file data. So point that out again, unstructured file data. So Nasuni specifically is a file service. So we are after your files. We don't do block. We don't do all those other things. we focus on file services. So we can scale both your primary and archive file storage without buying traditional disk. We can recover files faster from any point in time and get you away from the pain and cost associated with backup and recovery software. We can synchronize files across locations so that all users are working on the most current versions. And then we allow you to collaborate in real time across many locations. There we go. Our global file system can store both active and inactive data in the same namespace. You can select different storage tiers to put that data into. Thereby, you can kind of assign costs with that data and how you want to either protect or make it available. And we'll dig into that in a couple of the other slides. So it all starts with UniFS. So UniFS is our patented file system. It's part of our name. So Nasuni is NAS Unified, in case you were wondering. We're often mistaken for a fancy sushi bar. Again, we're the world's first cloud-based file service. We were really built to kind of replace, we're the new disk for the cloud backends, the object backends, so whether it's public or private. The global file system stores all your files in object storage. And then what we do is we cache objects locally for access and to ensure performance locally where the users are located. You get all the advantages of a traditional disk-based file storage, like fast file access, familiar folder structure, snapshot-based data protection, file locking, with all the advantages of object store. So infinite scale, low cost, access from all locations. I borrowed the phrase, I like to say Nasuni's the easy button for storage. So we're a great solution. Let's see, is this going to work? Ah, there we go, cool. All right. So the cloud is the first component. So in the cloud, we build a single namespace. That's where we store all of our customers' data. And this is not the Nasuni cloud. This is your cloud. This is your Amazon S3 storage account. Okay? You're using Nasuni as the service to move that file data, move those objects there. So the cloud is the first part. That becomes the central hub. That's the single repository for all the data enterprise-wide. And then the second part of the equation is what we call the Nasuni Edge Appliance. So the Nasuni Edge Appliance, think of it as a traditional storage controller. This is an on-prem or possibly in the cloud storage controller. We call it the Nasuni Edge Appliance. It runs it's available in a hardware appliance or a virtual machine. It's the local access point for your users. So if you have traditional file servers today, we're going to just lift and shift. Nasuni's going to go right in their place. Your users are going to be able to still access that storage with the same names, the same UNC path, the same map drive. It all transfers right over. Again, we act locally to cache that data and the metadata of the most active in-use files. And then everything else is kind of tiered off to the cloud. Sorry. To both the users and the applications, though, we appear just like traditional NAS. So this is really important in that, again, from a user's perspective, things don't really change. We do it at a very small footprint at the edge, typically about 80%. So if you have 100 terabytes in the cloud, we might suggest something like a 15 or a 20 terabyte cache locally. So we're thin provisioning at the edge. We also support all the standard file sharing protocols like SMB, CIFS, NFS. You can also add in things like HTTPS and FTP. And for authentication, we also support Active Directory and LDAP. So again, we tie right into your network as usual. We authenticate against the domain, and we're off and running. So during the kind of day-to-day operation of Nasuni, here's what things look like. So we have an edge appliance, and we have the cloud. Users create new files at the edges. During a snapshot schedule, we go ahead and we take that file, we move it into objects, we dedupe and compress it. We encrypt it with AES encryption keys that you, the customer, control. They stay on-prem. And we go ahead and move that into the cloud over a TLS 1.2 protected HTTPS connector. So we're just calling the Amazon S3 API to move those objects into your storage bucket, into your S3 account. It's pretty standard stuff. Once that object arrives in the cloud, it's then stitched together with UniFS, and it produces a versioned copy of that particular file. Now, on subsequent reads and writes, users can then edit and save that same file. We go through the entire snapshot process again. But then what we do is we add in those objects that create the changes for that file. And again, we represent another point in time backup or recovery of that particular file. So as changes are added into the system, we can make that another recovery point, and you can always go back to that version. When we move those edits of that file, we're doing it very granularly, typically at the byte range. So we understand byte range, dedupe, and compression. We're saving you as we transmit both in and out of the cloud. And then once those objects land in the cloud, the file system in the cloud is actually a worm file system. So it's immutable by design. It's one of our core patents. It's a great feature in that you can always ensure that once an object is written into Nasuni, it can never be edited or modified. So we can ensure that that data never changes. All you would do is you just either recall previous versions if you ever wanted to roll it back. So how do we leverage AWS? So AWS has been a partner of ours for quite some time. We have a number of different services that run in AWS. It all starts with, initially, just the S3 storage tiers. So Traditionally, most of our customers will pick either the S3 standard or the S3, I guess this one, IA, infrequent access. Typically, you would store your primary, your tier 1 data in the standard tier. You may choose something like infrequent access for like maybe a pure archive or data that's less frequently accessed. Of course, you guys know there's different charges for those. But we have the ability to do that in Nasuni and still give you, again, that single namespace to stitch it all into. So we make it very easy to manage. Intelligent tiering is something that's currently in QA with Nasuni. So that's a feature that's coming down the road. If you guys are up to speed on that, what Amazon is offering is the ability to take objects that are stale and old around certain parameters and move that from standard into infrequent access. And that ends up saving you money, right? Because you're moving it between those less costly tiers. Nasuni also supports Direct Connect. So if you have an AWS Direct Connect, which is essentially like a VPN into Amazon, we'll go ahead and transit that network connection as well. That's great for two things. In that, one, it reduces your bandwidth costs at the edge because you're not paying your internet provider. You're riding that Amazon pipe into AWS. And then you're also getting consistent network performance. And that's really important. That's what most of our customers do Direct Connect with, right? AWS has a pretty tight SLA. They'll say, hey, if you're on a Direct Connect, I'm going to give you this much bandwidth, and I'm going to guarantee you this much latency. So you know your time to first byte, your data retrieval times, those sorts of things are going to be pretty consistent. Two other big services that are part of Nasuni that all run in AWS are what we call the NOC, the Network Operations Center, and the Nasuni Management Console, or the NMC. So the NOC in AWS is really a collection of different AWS services that Nasuni uses to monitor the health and the status of both the storage and the endpoints from our customer's view. So a lot of different things stitched together. We monitor the service and all the edge appliances. One of them is a Global Volume Manager. That's what actually does all the orchestration of the data movement throughout the service. So if you have offices in San Francisco and LA, and you're synchronizing data between the two, that happens under something that's called Global Volume Manager. We also have Global File Locking, which I'll get into in the next slide. We also have a service within Nasuni and AWS that manages all your DR configurations. So if you lose an appliance, we have the ability to actually bring that back in a new hardware or virtual machine in about 10 to 15 minutes using a bundle, basically a profile of that particular edge appliance that we've backed up and stored in the NOC, which is really in Amazon. And those services also alert any problems or issues back into Nasuni. So many times we're actually proactively alerting our customers to problems they have through our support organization. So we'll see things that might be happening on your edge appliances or with your services maybe before you do. And we're going to go ahead and help you guys, make you aware of that and help you figure out what's going on. Next is the Nasuni Management Console. The Nasuni Management Console is really different from anybody else that does anything like us. There's not that many people. The NMC is a single pane of glass for you to manage the entire Nasuni service from, and gives you a window in your back end on Amazon. It's just a virtual machine. It's fairly lightweight. Most of our customers will run it in the data center, maybe close to the help desk. You can run it entirely in the cloud too, as well, if you like. It gives you full control and monitoring over the Nasuni service that has role-based access, so that's really nice. You can have your administrative views. You can have your maybe just monitoring type users. You can have people that can create storage but can't delete it. You can have people that can manage encryption keys. So lots of great stuff there. And we make it very easy to configure all your sites and the way you actually want to deliver storage. So again, it's the easy button. The NMC has the ability to templatize deployments. So if you've configured one edge appliance in a particular way, you can basically copy those different configurations and apply it to a new appliance. And you have the ability to, let's say, if you have 50 edge appliances, you could select 35 of them and change one configuration on it. And you're just doing that from a couple mouse clicks in the management console. So again, it's the easy button for storage. And then, of course, we get into global file locking. So again, global file locking is an orchestration layer, another orchestration layer that runs in Amazon. It allows for real-time collaboration from 2 different sites, but on the same data set. It runs on DynamoDB, if you're interested. It runs in dual availability zones. We have 2 distinct service locations. We have a US West that covers, US East in Virginia that covers North America, and then we have an APAC lock server as well. So what happens with global file locking is when a user opens a file from headquarters, we're going to go ahead and make a quick call up to the NOC, and we're going to check for the status of the lock on that file. We're going to go ahead and return a lock. No user has this open. We'll go ahead and make that read-write to that particular user. The file is opened, and within the Nasuni service, we're going to go ahead and place a lock on that file, and we're going to advertise that globally so everybody knows. So if another user comes in from a remote office, again, they make a request to open that file. We're going to make a quick check to the lock service, and we're going to return with a lock denied because the file is in use. And at this point, we're going to transmit that back to the user. We're going to let them know that the file is locked and you can't have access to it. So we're giving read-only access. Now, file locking is interesting in that what we're doing is we're just moving the semantics of the application, that locking of that application across Amazon. We're not actually we're not creating the lock. We're letting the application do that, but we have the ability to make sure that all other sites that are accessing that data can then verify and either get the lock or not. So if you have an application that locks, we're going to carry it through. If the application doesn't support file locking, we're not going to make it magically file lock. So again, a great service. This allows multiple user access from the same sites on the same data set without people overwriting each other's work and ensuring that your versioning is consistent. So, So we'll look at our Nasuni and AWS customers. So Perkins & Will. This is one of their buildings that they designed. Perkins & Will is a global design and engineering firm. They're headquartered in Chicago, Illinois. Fairly large company. They're about 2,200 employees worldwide. And they have major locations on about 5 different continents. They haven't always been big, but today, Perkins & Will has about 1.4 petabytes in AWS. So it's a pretty good data footprint. They've got 29 Nasuni Edge appliances that are dedicated for Tier 1 data access. So this is their most important sites and their most important data sets. They have about 56 total. They operate in 5 different Amazon regions. And a lot of that depends on the GDPR and some of the local or regional requirements of those sites. So they're doing business in Europe. They're doing business in APAC. They're homing their data in those different AWS regions to comply with that. They've got 2 sites that are dedicated to DR, and with Nasuni, they can fail over completely in about an hour. So this is great for a company of their size and somebody that's got a lot of stuff going on in a lot of different countries. They have a problem in one site, they can just fail over. They can do an entire failover in about an hour. They also have 3 EC2 appliances that are running. That's a Nasuni Edge appliance running in EC2 that they're doing some bulk data process and some advanced AI stuff on. So not sure if I mentioned this earlier, but we have also the ability to run entirely in the cloud as an EC2 instance. So again, with Nasuni, you could have a hardware appliance, you can have a virtual machine, or you can run purely in the cloud in EC2. What that's done for them is given them file access between about 24 different design studios and allows them to synchronize, collaborate, and share all those files. When they started with us as a customer, they were looking at a traditional storage, a hardware refresh. We saved them about 60% year over year. They started with 40 terabytes with us about 5 years ago. They've grown to about 1.4 now, almost 1.5. And they got to get out of that 3-year refresh of hardware and licensing for backup and DR. Speed of business is really important to them, so bringing new offices online, they went from 6 months to 1 month with Nasuni. They no longer had to go out and buy storage, provision it, stand it up, power it, cool it, configure it, get it out to users. And they do a lot of M&A, so acquisition and the speed of bringing those new companies into Perkins & Will is really important. So they went from about 12 to 3 months. And then, of course, the easy button, IT productivity. So allowing your storage admins or your IT staff to work on more pressing, more important projects and not kind of handhold storage every day. And then, again, giving them a single unified namespace within Amazon really adds to their AI initiative. They've got their, with Nasuni and our customers, since your data is in the cloud, you can now use all those other cloud services to run against that data. So you stand up an EC2 instance, you now have file access in the cloud, and you can run business intelligence, artificial intelligence, whatever you need to do against it. You don't have to bring that data all the way back to an office or a data center. You do it all in the cloud, right? So that's got a lot of benefit for both scale, obviously, and costs.